I believe it's time for a shakeup. Time to showcase the stiffness of Markforged 3D printed parts in a new way. A way that doesn't depend on someone's strength. Just like how people are blown away when large weights are hung from toothpick bridges, heavy weights applied to a 3D printed part would elicit the same reaction. These thoughts are what led me to the idea for this webinar. What if we could 3D print a step stool? I guess there's only one way to find out. The stool is really pretty simple, kind of like a first project you'd see in an intro to woodworking class. Given the dimensions of the stool and the build volume of the printers, I know I will need to break the stool up into separate pieces. Once I know how the stool will be divided, I like to think about how each piece should be printed. This planning is important because FDM 3D prints, like the ones produced on a Markforged machine, have an Achilles heel. The bonding between layers along the Z-axis is not as strong as the bonding between individual extrusions in the XY plane. In other words, FDM 3D prints are anisotropic, kind of like a block of wood. In this analogy, we know the wood's grain direction and the direction the force is being applied. Therefore, we know how to orient the wood to make splitting it easier. The same thought process applies to orienting FDM 3D prints, only this time, we want to orient them to make splitting it much harder. If we orient the different pieces so that the grain direction is perpendicular to this force, we will maximize the strength of the stool.